Alright, so this is your introduction video to right triangle trigonometry and SOHCAHTOA. Now I hope you already went through this investigation on your own and you're just watching this video to kind of double check your work. Okay, so we're given this triangle that has a 90-degree angle, 30-degree, and a 60-degree, and you have to draw your own, okay, and hopefully you did that. And it asks if everyone's triangles are similar to each other. And they should all be similar because if we remember from the previous unit that if all the angles are equal in a triangle, those triangles are similar. And that was your angle-angle sufficiency condition. Okay, in this case, I didn't draw my own triangle. I just measured the lengths for the triangle that was given to me. Okay, so I measured AB, and it was 72 millimeters. BC was 36, and then AC was 62 millimeters. Now, question 4 is about labeling your triangle. Okay, so our hypotenuse, I want to go over this, is always directly across from that right angle. So this right here is always the hypotenuse. From there, there's going to be an angle that's your reference. In this scenario, they told us that 30 degrees. Everything is with reference to the 30 degrees. Now, my opposite side from the 30 degrees is the one that if I were to draw an arrow, it's the line that I hit. So this is my opposite, BC. Which was 36 millimeters, and then AC, the leftover, is adjacent. And adjacent just stands for beside. It's the side beside the angle. Okay, so now we're going to determine some ratios. Opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Now, if you compare this answer to everyone in your class, everyone should actually get the exact same answer. Okay, so my opposite was 36, my hypotenuse was 72. When I plug that into my calculator, I get 0.5. And everyone, regardless of what triangle they had, should have something very similar. Adjacent was 62, hypotenuse was 72, and I get 0.861. And last one, opposite over adjacent, and I got 0.581. Okay, so that's great. Now, they told us to go to our calculator, okay, and type in a few things. Sine 30, and you should have gotten 0.5. That is actually matching your opposite over hypotenuse ratio, okay? And then they asked you to find cos 30, and cos 30 was 0.866, and that's really similar to your adjacent over hypotenuse ratio. And then tan 30 was 0.577. And that one was really close to your opposite over adjacent ratio. So all of these ratios, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, they are all trig functions. They are all trig ratios. And if you look at your calculator, you have that sine, cos, and tan. So sine of any angle is the same thing as dividing the opposite side by the hypotenuse. Cos of any angle is dividing the adjacent over the hypotenuse, and tan of any angle is dividing the opposite side by the adjacent side. Okay, we're going to try another example over here. So in triangle XYZ, theta is 30 degrees, and this is going to represent our reference angle. Okay, so I'm going to draw that in. This one right here is theta, and that's 30 degrees. Theta is just a Greek letter, and it represents any unknown angle or any known angle. Okay, we're going to label all of our sides opposite, adjacent, and hypotenuse. So hypotenuse is always directly across from that right angle, so it's the 10. My opposite is across from the angle that is given to me, so x would be my opposite, and then the leftover y is the adjacent side. Okay. Given the three ratios for 30 degrees, determine the value of sides y and z by following the steps below. So sine 30 is 0.5, and that means that the opposite side is 50% as big as the hypotenuse. So let's determine x. Well, x has to be 0.5, or half, of the hypotenuse, and the hypotenuse is 10. So that means x should be 5 units. Okay? So that way, if I were to do opposite over hypotenuse, 5 over 10, I do get that 0.5 that we saw in the previous example. Let's try cos. Cos is adjacent over hypotenuse, but cos of 30 we saw was 0.866, which means cos is going to be 86.6% of the hypotenuse. So I'm going to multiply my decimal by 10, and for y, I get 8.66 units. So if I were to do 8.66 divided by 10, I actually do get that ratio. And you can do a similar method for tan theta. So if I were to divide 5 by 8.66, I'd expect to get that 0.577 that we got in the previous example. Now what we just did here to solve x and y, this isn't the actual method we're going to be using to solve sides, but it's just to see the connection between the different ratios and what they actually represent when you plug it into your calculator using sine, cos, and tan. The most important part of this lesson though is really how to label your triangle. Okay, so in triangle JKL, what side is the hypotenuse? Well, it's the one directly across from my right angle, so it would be JK. Name the side opposite angle K. So because everything is with reference to angle K, that's going to be my reference angle. So opposite angle K is at 3, which is side JL, and adjacent, so beside angle K, would be KL, which is at 4. Now we're going to state each ratio. So sine of my reference K is equal to opposite over hypotenuse, so 3 over 5. Okay, now over here, okay, sine K, we don't know what the angle is. That's why we wrote sine K. Make sure anytime you write sine, cos, or tan, there is an angle attached to it, whether it's a variable to represent an unknown angle or it's an actual angle itself. You can never write sine equals 3 over 5. Sine is not just a made-up thing. It is attached to an angle. So sine K, sine theta, sine X, or whatever it may be. And also notice our ratio is different from what we've been dealing with because our angle is no longer 30 degrees. Okay, cos of angle K would be adjacent over hypotenuse. My adjacent side is 4 and my hypotenuse is 5, so that's going to be 0.8. And finally, tan K is opposite over adjacent. Opposite is 3, adjacent is 4, so that's going to be 0.75. Okay, and again, here we're not actually solving anything, we're just getting familiar with those trig ratios. This page I just want you to read through, okay, kind of goes over SOHCAHTOA and your different trig ratios, but I will point out some things. Okay, so what we're dealing here, sine, cos, and tan, that opposite over adjacent, that kind of thing, it's only for a right triangle, okay? Theta is just used to write out an unknown angle, to represent an unknown angle. Okay, the hypotenuse is always the longest side, and it's across from the right angle. The other two sides, opposite and adjacent, depend on theta. So if you look at these two examples, when theta is here, this is my opposite, that's adjacent. But if theta is up at this corner, then this is my opposite and that's adjacent. So they actually flip. But regardless of the example, the hypotenuse is always across from that right angle. Okay. Now the main formulas we have for right triangle trigonometry is sine theta equals opposite over hypotenuse, and that stands for SO, like sine opposite hypotenuse. Then we have cos theta equals adjacent over hypotenuse, so that's CA. And then tan theta is opposite over adjacent, which is your TOA. So this is just an acronym to help you remember everything. So this right here, super important to remember. Okay, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent, and all three of those formulas are written in SOHCAHTOA. Just make sure you remember SOHCAHTOA properly. Okay, and that's it for SOHCAHTOA, and we're going to be using SOHCAHTOA to solve for sides and angles in the next 2 lessons.